All right, so management and configuration, self-configuration, remote configuration by service, and that another thing is that the service provider can configure it. They can send some commands from there and say, well, now this guy has not paid the bill, stop the service. You know, the minutes are over and no more data. Things like that, right? So remote configuration. Femtocell senses the channel to detect neighboring cells and may broadcast messages for the neighbors. So everything is basically remotely programmable or self-programmable. Alright, so much about femtocell. Now, I think we are going to talk about the same intercell interference. But now it's not just intercell interference coordination, it is enhanced. So now I noticed another change. They already used evolved in the LTE, long-term evolution. So you cannot say LTE evolved because that would be long-term evolution, right? So, so they are using the word enhanced now, everywhere from now on. So everything is enhanced. Enhanced intercell interference coordination. It would have been called before evolved intercell interference coordination. EICIC is enhanced. ICIC is that intercell coordination, but now we have a better one. So it sends a load information message to the neighboring E and B and per physical resource block, and the neighbor adjusts the DL power level at those blocks. So now we are going to do even better than before. Before the UE figured it out that I am getting so much power from here, so much power from here, and that is very long time average. Alright, now we are not going to do long time average, we are going to do frame by frame. In the first frame I got this much, in the second frame I got this much, and third frame this much, fourth frame this much. So every millisecond we have the number of interference. And then we could coordinate by the millisecond, by the frame, by the subframe. So, for example, we could say that I really need to talk to this UE on these two subframes. Okay? And so this guy will not transmit anything in these two subframes. It will transmit what they call almost blank subframe, ABS. And the ABS will simply have a coordination information. So we know that it is not down or it is not failed or anything. It just says, okay, I am there, but I am not talking right now. Okay, ABS, almost blank subframe. And they are there so that the other station can talk to the mobile on those subframes. And so this is called enhanced intercell interference coordination. So you can see, and this is continuing for the next 2-3 lectures, that the things are becoming really, really complicated. Now you would think that a little phone that you do has all this logic. Yes, a lot of things are being done in the microsecond, millisecond level to figure out every second what will happen in the next millisecond. So this is EICIC. All right, ICIC was when we coordinated, we did multi-point coordination, this and that. Now EICIC is when we coordinate subframe by subframe. Right? It is based upon when we need to transmit and how much we need to transmit. If suppose this guy needs to transmit a lot of information, they will say, okay, please blank out maybe 5,000 subframes. And it will not do 5,000 in a row, it will do every 5th frame or something, so that it can serve its own customer as well. Right? So there is a coordination. So anyway, EICIC. Is it clear? Yeah. ABS. ABS is almost blank subframe. So there is data here, there is data here, there is data here. Here there is no data. There is little bit of control. That's why it is not fully blank. But there is little bit of control which says there is no data. Okay, every frame contains the control and data. Control and data. Control. Control is a map. Control basically says that, okay, in this subframe, the first block is for you, second block is for you, third block is for you. So there is a whole map of what is where the data is for whom, right? So that map will be there, but the map would be blank. It will say there is nothing for anybody here.
What are those pictures of the frames, the blue and the red one?
Okay, so the red one is coming from this tower, blue one is coming from this tower. Red one is coming from the left tower, blue one is coming from the right tower. right? So these are the frames which are coming from the right tower. These are coming from the left tower. But since the left tower wants to talk to this UE, it will use these two subframes to talk to that, and exactly at those two locations, this will not do anything. It will send a blank subframe. Carrier aggregation with cross carrier scheduling. Now we already saw carrier aggregation, but now there is basically a little bit more complicated one with cross carrier scheduling. So what we are going to do is that there is a control channel. As I said, control channel basically is nothing but the map of whose data is where in this cell. On the other side, basically, there is also a map for the uplink, where in the downlink it will say, okay, in the next uplink frame, you transmit in this carrier frequency, you transmit these carriers, you transmit these carriers at this time. So there is a map for uplink and there is a map for downlink. Right? Those rectangles you saw. So those rectangles are in the map. Map has the information as to what is the username, where the rectangles are, that means what frequency they start, what frequency they end, what time they start, what time they end. That rectangle is specified in the map. Okay, so that is called control, and that whole thing is called control channel. Okay, so here, if you see this transmission has two frequencies, blue and green. And the green is the main carrier, primary carrier, and therefore the control is in the primary carrier. Here is the map. This map will indicate to all the users who are in the blue, who are in the green, and where they are. Right? The map covers both the carriers. So everybody, the advantage of this is that everybody listens to only the primary carrier first. If they have something that they have to get, then they will go to the secondary carriers. So basically, physical downlink control channel PDCCH is in the macro cell, and a small cell is sent on different carriers and maybe at a higher power than the traffic channel. So okay, so that's another point, is that there are two carriers, both of them are using both carriers. So this one will use this as the primary, and this can use this as the primary. So when this sends out its signals, it uses this as the primary, the blue one, and the map is here for the blue, for the things coming, for both blue and green coming from here. So whoever the UE is listening to, they will follow that map. But the advantage of using different maps is that now everybody gets the correct map. Because if you got the wrong map, you are in trouble. Right? The data will not be delivered. So the maps, are maybe sent at a higher power and now on different frequencies as well. A UE can talk to both BS using control channels on different carriers. And also the UE can talk to this side using the primary carrier here and talk to this one using the primary carrier there. Yeah.
So the map is like the beacon and the pointer and N and AC. Yeah. Map. Is it the same as beacon and
beacon? Okay, so we use the word beacon in the wide area network, in the net world. Okay, right? This is telecom world, and so this is not the same as beacon in some senses, because I am transmitting the whole thing. Yeah, so the some part of the thing is this using for control. Some of the symbols are being used for control. And so it has the same function actually. I mean, I can see that it is almost the same function, because in that control I will say, okay, who is sleeping, who is not sleeping, who should go to sleep, whose packets I have. All of that is here. Okay, but yeah, so they don't call it beacon.